Hi guys. Sorry about yesterday. I got the textbook images a little too late. Like I wrote on the stream on Google Classroom, we will be working on 12.5 and then we'll actually take a quiz and then we'll go back to 12.3 and 4 for probabilities and then we'll wrap up this chapter and start on trigonometry. So today we are going to learn about special distribution called normal distribution. So when in statistics, if you say normal, it means very specific things. So we're going to learn about what that is, and then we're going to talk about the empirical rules that only applies in this situation, and we are going to learn how to find and interpret z-scores. So let's review what we have learned so far. So we learned about distribution and how they can be described. So there are 4 elements. I'm going to emphasize some of them again today, just in case you didn't get it. So there's shape, outlier. Outlier we didn't talk about it. We talked about it as like an extreme value, and we learned how to find them using box plot, but we never really got into it. And the center and spread. So center is when I talk about mean, median, mode, and spread is standard deviation, interquartile range, and range. So let's talk about that. Okay, so I have some example distributions here, and we're going to use what we have learned so far to describe the distribution. I mean, the answers are right there, but I'm going to explain a little more. And which measure of center and spread should be used for each situation. So the first one, it's a unimodal. So we talked about modal. So uni means one. So that means it's one peak. And you see the peak right here. And then it's skewed to the left. So skewed to the left meant that you have more extreme values. So it's like a spread out in the smaller values. And then skewed to the right is the opposite, right? You have a tail that goes to the right hand. And this one is also unimodal. So there could be an outlier. There might not be an outlier. There's nothing we can be sure about just looking at the histogram. And we talked about why box plot is more advantageous when you are trying to look for outlier because it shows the value itself, whereas histogram, you will never know for sure. So since there's no particular data that goes with this distribution, so we can't really say center is this, spread is this. But because they're a skewed graph, you're going to use median to describe the center, and median is always paired with interquartile range. So IQR will describe the center. And then we move on to the next two. So this one is bimodal, and you might be like, why is it bimodal? Because this is not as high of a peak. But you want to see what is happening around it too. So if that is one of the higher value than other things, then we consider this point quite important. So this one I'll probably describe as with mode, and I'm going to distinguish this mode and this mode for center. And then for when you choose mode, we tend to go with range because standard deviation or IQR has a very a specific match to it. But mode, like I said, is not really used all that much. And therefore, when you choose mode to describe the center, I like describing the spread with range. This is I guess slightly rightly skewed, and the reason they would say that is when you compare mean and median. When mean is greater than median, then it's skewed to the right. If mean is smaller than median, then it's skewed to the left. This one is unimodal and it's symmetric, right? It doesn't mean that it's exactly the same when you divide it in half, but it's more or less the same. So in this case, we are going to use mean and standard deviation to describe my center and the spread. Bimodal symmetric. So even if it's not unimodal, it could be symmetric, and this is the case. So the peaks are about the same, and it's almost like there is a half. If you half it and fold it in that dotted line, then it's symmetric, right? I'll still use mode because it's quite important. But I will definitely look at other measurements too, just to be sure of this distribution. And I will describe it with range as well. Because mean and median for this case, it's very possible that they seem equal or like they wouldn't look very different just because it's a symmetric. Again, there's another one with the bimodal symmetric. So in that case, the peaks are starting from the very beginning and the very end, and then there's like a big gap between those two peaks. All right, so some of the words that I use, like gap, peaks, unimodal, bimodal, skewed to the right, skewed to the left, symmetric, those are all important words to describe shape. Center, you have noticed, I've only used mean, median, and mode, and it is important to look at all three of them, but when I try to describe a distribution, I only choose one. And usually it depends on what I choose for center. The spread, the measurement of spread is determined, and so mean is always paired with standard deviation, median with IQR, and mode often than not range. So today what we're going to actually learn about is something called normal distribution. What's important about normal distribution is it's perfectly symmetric, and mean and median are equal in this case. They're absolutely the same. So symmetric, mean and median, the same, unimodal, and it has a mean is in the, so this little symbol is called mu. This represents mean, right? So mean is in the center, and there's a little symbol sigma. This represents standard deviation. And like I said, standard deviation is based off from the mean. So it's like you are one standard deviation less than the mean and one standard deviation more than the mean. So that's how these points are determined. And we're going to look at this number, this percentage a little more carefully using the empirical rules. So in a normal distribution and a normal distribution only, empirical rules apply. So empirical rule is sometimes called 68, 99.5, 95, 68, 95, and 99.7, I think. I guess we'll know when we add them up together. And so what that means is that within the first standard deviation, there will be 68% of the population. So this data that I shaded right here in the pink is 68% of my population because the area under the curve is always 100% because you have to represent 100% of the population, right? So area is always equal to 1. But then if you go 2 standard deviation away, it adds 13.5, 13.5. That's 27. So if you add 68 plus 27, that's 95. So 95% of the data is under 2 standard deviation away. And then when you go 3 standard deviations away from the mean, you add another 5%. Oh no, it's not quite 5%. This is a little bit off. It's like almost 100%, okay? So usually rule of thumbs when you're looking at the distribution is that any data point that is above or below 3 standard deviations, so absolute value of, 3 standard deviation, then you have an outlier because you're supposedly contain 99.7% of the data. And if you're in that 0.3%, that means you're outstanding, whether it's like an extreme low value or extremely high value. So how do we know how many standard deviations away? Well, there is something called a standardized value. So a standardized value is sometimes called a z-score. So the standardized value, z-score. So you guys will be taking, I don't know if you've already taken like a PSAT or anything like that. So when you take a standardized exam, that will always show you this kind of graph, this bell curve, sometimes called bell curve, the normal curve. And then it will highlight you and say you are the 95th percentile. What does that mean? It means that you are above 95% of the population. So obviously because it's SAT, as you are farther away from the mean in a positive way, that means you are more exceptional than the other way around, right? So how do you compare different values? Well, we have to compare the z-score. If your z-score is big, that means you are that many standard deviations away. So basically, z-score is a measurement of how many, so the measurements of number of standard deviations away from the mean. So if my z-score is 4, for example, if my and then this is how you find z-score. Z is your value minus the mean over standard deviation. So let's say my z-score was 4. That means that I'm 4 standard deviation away from the mean. So I'm more exceptional than 3 standard deviation away, right? All right, so let's look at some of the problems, what kind of problems you could see using this kind of concepts. So number 1, it says a table at the right shows recent composite ACT score. It's another type of test like a SAT. It says determine whether the data appears to be positively skewed, negative skewed, or normally distributed. So I'm going to just like briefly draw this. So 13, 15, 19, 23, 27, 32, and 36. And know that this is just very, what's it called? Rough. So there's only one person here. And there's like a 9 person here. And there's a 19 person here. And 29 person here. And 27 and 12. What do you think? This one, oh, this 12. The shape looks something like this, right? So it seems like it's skewed to the right. It's definitely unimodal, but it doesn't seem like it's normally distributed or negatively skewed. So because the tail is on the right. So I would consider this as a positively skewed or skewed to the right. So positively skewed is the same thing as skewed to the right. Let's look at number 2. A normal distribution of data has a mean of 161. So mean is 161. And the standard deviation is 12. It says find a probability that the value x is less than 149. So let's see. So we need to find out z-score of x. Let's say x is 149. So then the z-score of 149 is 149 minus 161 over 12. So let's calculate that quick. And this gives me negative 1. Okay, so it's a 1 standard deviation away from the mean, but it's the other way around. So it's asking less than that value. And what would be the probability? Well, the area is also probability. So look at this 1 standard deviation away, and you have to add up these two numbers, 13.5 plus 2.5. So that's 16%. So basically, the probability of you having 149 or less would be, did I say 16%? 16%. Okay, so you're going to use that empirical rule distribution to calculate this. Mr. Bash gave a quiz, and the mean was 21, and standard deviation 2. What percent you expect the score between 19 and 23? Well, let me just draw the normal curve, okay? 21, 19, and 23. And then another standard deviation away will be 17, and then 15. And this would be 25 and 27. So the first one is 19 through 23, but this is 1 standard deviation away. And according to the empirical rule, that was 68%. It says 23 to 25. So it's this part right here. And even it's between 1 and 2 standard deviations. I'm going to look at that graph here. It says 13.5%, right? It's that shaded area. So the answer must be 13.5%. And then it says 17 through 25. So this is a 2 standard deviation away, right? Because it's 1, 2, 1, 2. And 2 standard deviation away, it was 95%. And so you can answer these questions using empirical rules because for this chapter, they're not going to ask anything else. Like if your z-score is like a 1.2, they're not going to ask that because you don't know how to find that yet. And I don't think you'll need to know for this class. Maybe you will learn it in pre-calc. But for now, if you know how to find the z-score, which is the value minus mean over standard deviation, and if you can utilize this, this graph right here, and you'll be able to solve the question without any problem. Just remember, area is the same thing as a probability. Okay? I will see you tomorrow.